In this video, I'm going to attempt to make an explanation for the protocol buffers format and specifically how it's used in swordigo. So swordigo uses protocol buffers to encode data for scene files, SCL files, and all of these data types. The main thing you should know about protocol buffers is that it's a binary format. This means you can't open it in a text editor. You will need to use a hex editor. The main reason for this is that you will need to see the decimal value and the binary value for each byte. So right now I'm using hex edit, which is a browser editor. I recommend this one because it works just the same on every type of device. So you can see I have the data inspector on the left. If you're on a mobile device, you will probably need to click a button at the bottom with the letters L and E in it to be able to see this data. The protocol buffers format is pretty simple. First, there will be one byte that tells you what type of data you're looking at. Then optionally, it may have a length indicator, a string pointer which will tell you the length of the data, and then it's followed by the data itself. So the type byte will tell us what the tag is. The tag is essentially a number that's attached to the data. You don't really need to know what the tag does at the moment. The wire type is important. This will tell us what method is being used to encode the data. So swordigo uses three different wire types. We have the var_int wire type, the len, and the int32. The var_int is pretty simple. Basically, it's used to encode positive integers. That means that it can't be a negative number, and it can't have a decimal place, essentially. It has to be positive and a whole number. So I have an example here, 08. So if we look at the last 3 bits in this byte, this will tell us what the wire type is. The first 5 are the tag, so you can see that the tag here is 1. And if the wire type is 000, that tells us that we're looking at a var_int. And the var_int is very simple. All you do is look at the next byte, and the decimal value of that byte, this is what the var_int is equal to. So in this case, I've just written a 5 here. The next type here, the next byte here, you can see the tag is set to 2. It's not really important. The wire type is 010. And 010 just means a len. How the len works is you look at the next byte. This one will tell you the length of the string. In this case, it's 4 bytes long. So we can just look at the next 4 bytes here. And you can see that these 4 bytes are just encoding the word fire, not for any particular reason. If we look at the next byte, the wire type here, 101. This wire type, you can probably already guess, is the int32. How the int32 works is pretty simple. Just the next 4 bytes here are the value of the int32. The problem here is that there's not really any way you would be able to understand what this value is. So you'll need to use a converter for this. I've been using this one by Greg Stoll, which is an online one. I'll put 2 links in the description to a couple of converters which I've found to be quite useful. If you're using this one, make sure you click this checkbox at the top that says swap to use Big Endian. And then you can just insert the value here, and the value I had before was 0000803F. And if I click this button, we can see that it's equal to 1. So I've essentially just encoded a 1 here. So that's the 3 wire types that are used in swordigo. The next thing I should tell you about is subblocks. So what happens if you want to denote a list of different entries? If you're using a plain text language like Lua here, you would probably use curly braces to have a list of items, sort of a sub block, and you can have various different items in here. And this essentially works the same way in protocol buffers. It works just how you would expect. You just have a len type here. So you can see this one, we have 0, 1, 0, that means it's a len. And the length here is b, which is equal to 11. You can see down here it shows that I've selected b bytes. So it includes all of this. And you can pretty clearly see that this is not a plain text string. So this shows us that we're looking at some more protocol buffers here. So you can see I just have a variant here, and I have another int32, which is equal to 0, and I just have a string here which has the length of this string is 2, so it's just these two dashes. So that's pretty much how the subblocks work.